Bismillahirrahmanirrahim. Mrs. Sophia Suhail is here, and now I'm explaining the topic of exponents and radicals. Okay, before the explanation of these topics, this I will explain in different parts because the topic is a little long, so I will explain in different parts. So, this is the part number 1. You can find out the different part. I will mention in the label of the video also. Part number 1. Before the explanation of the exponent and radical, I would like to explain about the product first. What is called a product? When we multiply any two numbers, we get the result. This result is called the product. The number which we obtain after multiplication is called the product. After multiplication of two terms or more than two terms. Okay. Then we can understand about continued product. Continued product means when we multiply several terms are multiplied together. Like okay, so 2 3s are 6, 6 2s are 12, 12 3s are 36. So this we obtain after the continued product. Okay, and then we must know about the factor also. This is the continued product. They are called the factors of this number. Okay, they are called the prime factor of this number. In this product also, these two are called the factor of this number. They both are 2 is a factor of 6, 3 is a factor of 6. So they are called the factors of that number. If the same factors is repeated several times, then product is called the power of that number, power or exponent. What does that means? That if the same factor like a multiplies so many times, then we will call a with the power of 3. Like 2 multiply 2 multiply 2 multiply 2. So it will be called as 2 power 1 2 3 4. How many times it is being multiplied? 4 times. So this is the exponent of 2. So in these expressions, like I write 2 times 2 times 2 times 2. 2 is multiplied to 4 to itself 4 times, so it can be written as 2 power 4. In this one, this number is called the base, and this one is called index or power or exponent also. Exponent. Okay. So index is the single form. Indices is plural of index. We call it exponent, we call it index, we call it power. Anything we can call this one, and this will be the base of that power, base of that index, or base of that exponent. Okay, now we will come to the laws, exponential laws. Exponential laws. Law number 1. Law number 1 is for any non-zero real number a. For any non-zero real number should be real and existing. Okay, a We can say a have some power like m, and it is multiplying to another same number with a different power n. If the base number is same and they have different power, when we are multiplying those numbers or those terms, we will write that term one time and we will add their exponents m plus n. This is the first law of indices. Means for any non-zero real numbers a can be any number. So a is m times, it's multiplying to again a n times, so it will be equal to the same base but the powers will be added up. I will apply it on the different examples. Example number 1, like if you are multiplying 2 power 4 to 2 power 5, base is 2, it will remain same and the powers will be added up, so it will become 2 power 9. You can solve this number on the calculator also with 2 power 9, or it can be solved, if normally we will solve, it will be very lengthy, like 2 is multiplying to itself 9 times. Yeah, like this one. But using the exponential law, it's very easy like this. You may have any mistake in multiplying like this, but here it will be easy and simple to solve, and there is a less chance of mistakes also. Second example I will give with another number. If it is given like this, 4 power 3, 4 power 2. So using the first law of exponents, we can write it 4 and add the powers 2 plus 3 plus 2. So it will be 4, 2 plus 3, 5, 5 and 2, 7, 4 power 7. This answer can be solved by using calculator also. If we use any other number other than any number in the symbolic form, even then it can be very easy. Like base is same, so it means if their powers, we can apply the first law of indices on this question. 2 plus 6 will be equals to m power 8. Another example, if the powers are always not positive, then this is a positive, this is a negative, even we have to add them, we have to add the exponent. Now a positive integer and negative integer, when opposite integers are added, always we subtract the digit. Means 7 minus 4 is 3 and sign of the bigger digit will be written negative. So minus 7 and plus 4 will be answered as minus 3. Minus 3 we can change it as a cube. Means for making the change, for changing the sign of the index, we can take its reciprocal, it will become positive. We will discuss this law also later. Law number 2. Law 2 is saying that for a non-zero number a, again I am taking a power m, and if it's dividing by a power n, so a, and after division means the, if the base is same and the numbers are dividing, so exponent will be subtracted like this. So I will take a few examples for this one also. Powers will be subtracted. 7 minus 6, 3 power 1, it can be written as 3. So easily it can be solved. X power n divided by x power 5. Then x 9 minus 5 and x power will be 4. Power 0, and if you got the power of 0, again there will be another law applied on it and it will become 1. We will discuss this law later. I just give the example that in subtraction any type of answer you can obtain. So a power 15 minus 12, a power will be 3. So all the relevant examples. I have explained if the two same numbers are divided, their exponents will be subtracted. Same numbers divided, exponents will be subtracted. Same number, same base dividing, exponents will be subtracted. Same base dividing, exponents will be subtracted. Next law we will explain now. Okay, law number 3, for any non-zero number, sorry, for a non-zero real number, a, we can say that if a already have a power and again we are taking another power on it, so this new exponent will be multiplied to the previously present exponent, m multiplied by n. Understand that one? That if there is an exponent and one more exponent is being taken, so this exponent will be multiplied to the previously present exponent. I'll give a few examples related to this one also, like 3 power 4 and then you have taken a square on it. So 3 power 4 will be multiplied to 2 and answer will be 3 power 4 2s are 8, like this. One more example I will take 5 power 3 and then we are taking 2 power 5 power 3 and 2 exponents will be multiplied 3 2 times 6. Its new exponent will be 6 after solving. Okay, let me revise this lesson now, that what I have explained from the start till now. That first I have explained about the product. If two numbers are multiplying, it's called a product. Okay, continued product, if more than two numbers are multiplying, so the answer we obtain or result we obtain is called the continued product. Factors, when the numbers are multiplying to a given number, so all these numbers are called the factor of these numbers, and this number can be divided by each of this factor, power or exponent. If one number or same number is multiplying several times, so the same number will be written as that number of times as its power or exponent. Like a is multiplying 3 times, so a will be written as it is, and how many times it is being multiplied, that will be its exponent. 2 is multiplying 4 times, it will be written as 2 power 4. Then we will discuss about the laws. Before discussing this one, I just repeat once again that what is the index or a power or exponent. 2 power 4 means 2 is multiplying to itself 4 times. 2 will be called its base and 4 will be called its index or power or exponent. Indices, we are using this word as the plural of the word index. Then I explain the exponential laws. Law number 1, that for any non-zero real number a, if a to the m power is multiplying again the same number to the different power, so number or base will remain same and the power will be added up. This is the law number 1, and we can apply this law on the different examples. 2 power 4 multiplied 2 power 5. Base is same, so 2 will be written once and exponents will be added up. 4 plus 5 is 9. Same number, same base, so exponents are added up. Same base, write them once, exponents are added up. I take this number with the opposite sign integers, means one is a positive integer, one is a negative integer. If the question is like this one, even then we can solve it in the same way, that base is same, the numbers are multiplying, so add the exponents. If the exponents are different or opposite integers, no problem, you can add that as it is, as we are solving the integers. For making the base like in positive exponent, so we will take the reciprocal of this one, it will become a positive one. Next law I have explained, for a non-zero real number a, we have taken that if they are multiplying like this, so their exponent will be subtracted. Same base are dividing, exponent will be subtracted. Same base dividing, exponent subtract. Same base, exponent subtract. Same base, exponent subtract. Next law, law number 3, is for a non-zero real number a power n, and it is taken to another power in the number. So both the exponents will be multiplied together. So 3 power 4 and it is taken to a square. So square is multiplied to the previously present fourth power. 2 times 4 is 8. New power is 8. 5 and 3 and then power 2 is being taken. So this power is multiplying to this power, and 2 times 3 will be 6. Now the exponent will be 6. We can call it as exponent, we can call it as power, or we can call it as index. Any one number, which one you like, you can call it, but you must keep these three different terms in your mind. Thank you so much. Hopefully you will like my video and prepare this topic properly, and it will be helpful for your learning towards the exponential laws. In my next video, part number 2 of exponential laws, I will explain the next exponential laws, inshallah. Thank you so much. Allah Hafiz.